So today I want to kind of take the next logical step in what we've come up with so far. So we started with some of the solid modeling, kind of the basics of solid modeling. Then we did a little bit of a deep dive into creating sketches to make our models. And then we did one that was kind of focused on parts for 3D printing. Then we did one that was focused on parts, sheet metal parts for sheet metal fabrication. And now I want to do one that focused a little bit more on machining, machine fabrication, CNC machine fabrication. And one thing that's very helpful, especially if you're having someone else machine a part for you, is communicating everything that's important about that part and what's important to make the part functional for you. And usually that requires a blueprint or a drawing. You know, some shops can work from a sketch on a napkin, so to speak, but most shops want to work from a blueprint or something a little bit more documented with more specifics that they can reference to make sure that they make what you want. So Fusion has a module built in to create blueprints or to create 2D drawings of your parts. So today's lesson is going to kind of go on a little bit of a exploration on how to do that. And if you ever have machining parts in the future, you know, this is a good way to specify critical dimensions or critical things that you need done. So what I have on here is this gear, which I know, Kevin, you have seen this before. But this is, you know, the 3D model I drew up from an existing part to try to get an idea of if it's something that we can have a machine shop create. And giving them the solid model or the step file would be something that they would use to generate like tool paths in their CNC machinery. And in fact, Fusion has a feature or a module for creating tool paths. I haven't really done much with it. Maybe someday I'll do a little demo as I figure it out, but I don't have a machine that can utilize that, you know, but you know, another, you know, machine shop would, or whatever software that they use. So they would take the step file, the solid geometry file, and they would use that to figure out, you know, the size of the material and the size of features and, you know, tool paths, you know, how would a tool, a certain shaped cutter, how would it have to move to, you know, create the different geometries. So, but even if they have the model, there might be specific things that you need to draw attention to that, and that's where the 2D print or the 2D drawing comes into play. Examples might be specifying even a material type, calling out specific tolerances. Typically, most CNC fabrication will hold, if you're in the inch system, about 5/1000ths of an inch tolerance on most features. In metric, it's about 0.1 millimeters, about 4/1000ths of an inch. So that's kind of like a standard tolerance. It's something that, you know, I'll still specify, but if you have anything that's going to be either a tighter or looser tolerance for whatever reason, you know, identifying that is a good idea. So to get started, when we create a drawing, we're going to go to the button on the left here, the design, and we have a few different options. Animation, simulations, manufacturing tool paths, and then the last one is a drawing. And we can choose from a design or from an animation. When you go to choose a drawing and to start creating a drawing, it's actually going to create it as a new file. So before I create it, I'm going to show you in my folder here over on the side. Like I have, you know, some part files here, and then there's drawing files after them. So when you create a drawing, it actually saves it as a new file. So you can open up just the drawing file, or you can open up just the model file. So let's go ahead for our gear here. If I go to start a new drawing from this design, it's going to ask me a few things here to set it up. I usually use most of the defaults. There's a few things I change for me. You know, we're going to go with the visible contents. We're going to create a new drawing. I don't have any saved templates. If you have a specific template or something that you like, you can, or you create a template, you can save it. The standard here is ISO. ISO is the the metric standard for paper size. So ISO is going to be like A4, A3, A2 paper sizes. In the US, because we use inch paper, 8.5 by 11, I'm going to choose the ASME, which then gives me the choice to make my drawings kind of standard American paper sizes. If you're in Europe or something, of course, you can use the ISO standards. They also don't specify portrait or letter format. You just have to know that there's A 8.5 by 11 or A 11 by 8.5. So one is portrait, and this one is landscape style, and this one is portrait style. But I'll hi kitty. I'll lay it out on a B sheet of paper, B size, 11 by 17. And if I click OK, it will start up a new view. And then here's our template here, or our paper. And you can see that it starts off with a title block. Again, this is just the default template. It starts with a title block, and it has the name. It will pull from your previous file, your folder, and then your actual part name. So to start, once we have our blank piece of paper, like drawing the solids or doing the sheet metal, Fusion has it pretty well laid out, going from left to right across the ribbon on the top. So the first thing we're going to do is bring in a base view of our object. And so this view is going to, I just remembered I had a hidden object on this, so I might go modify this once I place this. But we can have a side view of our object, and we can create which orientation we want over here on the drop down, right? So that's a front. This would be the top view, and then there's also a scaling factor. There's also options for if you want to display it as a solid or with hidden lines or dotted hidden lines or no extra lines. For this, let's make it 1:1 maybe. What size does that look like? Maybe even a little bit bigger. To 2, is that too big? Oh, I'm sorry, 2:1. That's too big. Maybe 3:2. Yeah, that might be good to start off. So when I click it here, it's going to make a 2D version of my shape once I place it on the workplace and click OK in the menu. It will think for a minute. And then there's our part looking at it directly from the top of the part. Now, there's one thing I am going to go back to that part and change before I continue. And that is I have a part of it hidden. So when I was making this gear, I had to, it's actually this body. I had to make a mirror image of it so I could do a test 3D print to make sure that the teeth meshed. And so there's this hidden part of my model. But I'm going to delete this bottom part here. Delete that. Okay. Now, so now we've placed our first view on the drawing. The little icon to the left is a projected view. So a projected view is where you project or look from a specific side. So if I wanted to look at the right side of this gear, that would be on the right side looking to the left here. If I wanted to look up, at the bottom, I'd be looking up. So if I choose projected, it asks me to choose the parent view. In this case, the only view I have. And then as I move it around, you'll see that, this is looking at that side. If I move it over to here, it's looking at it from the other side, the bottom, so that whichever way I angle it, it's looking from that direction. So we're going to do it from here. And place this view on the side, and I can click the little check mark here. That's where I want it. And it did draw it with my mirror image part. So let me see if I can, maybe I have to save this model. It should update. You know, again, part of the power of Fusion is it should update everything as you go along. But I'm not entirely sure how to update it. Oh, it's actually telling me right here. So a change has been made to the reference design. You can update the drawing with the button in the application bar. That might be here, or is there one up at the top? Update. Oh, maybe up here in the corner. Let's update this one. There we go. So now, since I had updated the model, it now updated the drawing to match. So this is my side view model. The side view isn't that, for this particular model, is not that helpful. You know, you can see the gear teeth curving around, and you can see the channel, the space between these little teeth versus the main gear teeth. But some of the things we can do in a drawing is to break down and look at things like a section view. A section view is where we would draw a line, perhaps in the middle or a certain part of this drawing. And, you know, if we had sliced the part and looked at it that way, which actually is the next tool in line on the ribbon, is a section view. If I click section view, it's going to ask me again to select a parent view, the view we want to start with. And then it's going to ask me to draw where my section line is. So let's draw it right through the center point. So draw it right like that. And then I've got my little check box here. And then I can place my my section view there. And so this is essentially, if I've made a slice directly in half through the part, we can see, you know, like the bore and any other things about that. Another feature we can do drawing wise is the next one over is a detail view. A detailed view lets us take we'll choose a parent again, and we can choose a center point, and we can make like a little circle that would be like a little blown up view of, let's say, a specific feature. And then I can you know, place that somewhere. So that's and I think, can I modify this? Let's make this 3:1. And then if I need to move any of the views, I can click on it and drag them around a little bit. But this way, we have like a bigger blow up. We can actually see the little angles on these little teeth here on the top. And then once we kind of have different views that we want to have, we could also we could also place a little three-dimensional view. I'm going to go back to a base view, and let's choose one of the isometrics. How about isometric? There we go. So I can put like a, we'll make this 1:1. So I could also put like a little 3D shaded view here as a reference, you know, in the corner, so that someone looking at the blueprint, or I could either make it shaded or a line drawing, so someone looking at the blueprint, you know, has an idea of what the 3D version looks like. If I wanted to make it shaded, I think I can go to edit this, and my styles up here. This is a line drawing, and then this is the shaded view. So then I can have a shaded one there to help somebody see that. The next tools in the ribbon. So there's another one here to the right of detail. This one is a break view. It has a description here, but this is like, let's say you have like a long feature, like a long piece of pipe. and or a long object, and to fit on your paper, the scale might be so small. If you have features in the ends of your object or your pipe, it might be hard to see. This view will kind of cut out a little chunk in the center of your object and make like little wavy lines, so that it can show you kind of the two ends and just like an approximation of what's in the middle. And then here you can create a sketch if you needed to create a sketch to draw something specific that you were trying to point out. Then we get to the modify tools and the ribbon. This allows you to move or rotate. You can also like click on one of your views on the edge, and when you get the blue box, you can then drag it and move it that way, or you can click on the little arrow tool and it asks you to select, your what you want to move, and then you can move it that way. So you can either transform, by choosing a point. I want it to go from this point to. I can either drag it or click on a specific spot to go to. We get to the next part of the ribbon. This is little geometry features that are useful to add. Like we have this section view here. We've cut into the side of the part. Because it's a round part, it's a good practice to put in a center line. So a center line here will, if I click on the two edges there, it'll draw a little center line. So now it's really clear that this is a hole, in a revolution of a part. I can also add a center mark to this view here, based on the center circle. Do I need to, maybe need a full circle part? Select a hole or rounded edge. That's what I'm doing. Let's see, maybe here. That's a full rounded edge. I wonder if because I have little chamfer on that, it's not happy. Interesting. I thought it would have popped in the center point there. This one, it'll make like kind of a crosshair. I don't know why it's not getting that feature. Well, maybe because of the complexity of this shape, there's no full centerpiece that it likes. You can also do center marks at a pattern. Let's say you have a part that has holes spread out throughout the part. You can use that. I actually have another drawing that I've worked on before. This solid model is a flywheel for an engine, and it's got holes in the center for mounting to a crankshaft, and then it has holes around the perimeter for a pressure plate. And so in my drawing, I've used that radial hole centerline feature to identify those holes on the outside and the holes on the inside. This is another example where I've taken a round part and I've created, the front view straight on the round part, a side view. This one I used hidden lines, so you can kind of see what's geometry that's happening on the inside. Over here, I've used the section view, so you can kind of see a cross cutaway to get a better sense for the two bores on either side for two different bearings. And then I've used a little, put in the little 3D shaded view here as an extra explanation. Going back to ours, the one that we're working on right now, we can also, there's this edge extension. If you have straight edges that need to touch somewhere so that you can measure off that, you can draw that as well. And then we get to now that we've kind of drawn features on our blueprint, we are now going to the dimension section. In the dimension section, we can create angled dimensions and linear dimensions. And this is where we can start dimensioning specific things. Like, let's say we're going to dimension this this bore inside here. So from this line to this line, we're going to specify what that bore should be. So as drawn in the model. And so this will pick up all the dimensions directly from the model. If you need to modify or change anything, you can. You can then type on it or like I can type in here. So the little arrows or the little greater than less than sign means that it has been picked up from the original model. But if I wanted to type something else, like maybe I wanted to make a tolerance on it, I can add something to this. So, or I can change the overall on the right hand side. You get a little window that pops up when you look at a dimension. I can change the units. I can put in symbols, like if it's a diameter symbol or something like that, and like tolerances down here. I can give it a symmetric tolerance. So symmetric means like it's plus or minus point. It just popped up with 0.01. That's obviously very tight. But this being a bore that a bearing goes into, I would say, maybe we want this to be non-symmetrical. So we might want this to be like maybe plus 0.1, but minus 0, meaning that it cannot be any smaller than the 42.5, but it can be up to 1/10 of a millimeter larger. So then if I close that, it puts that in on the measurement there. Now, why I would put measurements, I wouldn't put a measurement for every object or every dimension on here. There's a lot of stuff that a machine shop would pick up from the solid model, but there's specific measurements that I might deem critical that I want to make sure that they've checked. One thing for putting measurements on a drawing is for inspection purposes. A lot of shops actually have an example here of a part. Here's a scan of a print. This is a little aluminum cover, and so on this, this actually has a lot of dimensions, probably more than needed, but it has lots of different dimensions for all the different features, the little cavity and the holes. And so the machine shop that made this has put a number next to every dimension that's on there. And then what they've done is supplied another page that this was made by a machine shop in China. They have supplied an inspection report where they list, every dimension here. So they made 2 of these parts. Dimension 1 was 8.89 millimeters, and then they actually have the actual numbers that it measured up to, 8.984 and 8.990. Both of those are within the tolerance, and so the parts are good to go. It does also have here, they have a column for testing equipment, where with the letters they tell you how they've actually measured this. E is probably like a caliper, yep. So tool E is a vernier caliper. Tool J is a profile projector. It makes like kind of a shadow projection of it that you can measure. Hole gauge, I think this is a misspelling of a hole gauge. But anyways, an inspection report. So a machine shop, can do an inspection, a final inspection for you based on your part. But that is going to be somewhat labor intensive. So if you include, 40 dimensions for them to check, that's going to take time that they're going to have to spend doing that. So I would encourage you to, only put on critical dimensions that you really want an inspection report for, that you want to see that they've held. For this part, again, this bore is critical. I also think that the overall dimensions, so there's actually 2 kind of mating surfaces on this top surface here and the bottom surface, which is really, if you look, it would be this surface to that surface. So that might be another one that I would put in a dimension for. So that might be from, from this to this surface here, right? And so this is another one that, I might say is critical and needs to be, within a certain amount. There are different dimension systems. Currently, we're using the ordinate dimension systems is to define a specific point and then measure everything off of that. Where if you look at that example that I gave here on this print, you'll see that there's an edge or a surface that's listed as 0.00. So that's the base of it. And then they have everything dimensioned. So like this face here, this surface is 50 thousandths far away from this one. Then this surface is 150 thousandths, 0.15 away. And then this surface is 0.35 away. This is an alternative way to dimension as opposed to what I've done here, where you have extension lines and arrows with a dimension showing there. So this is another way to go about it, and Fusion will let you do either. You can put in dimensions for diameters. So let's see, I'll just throw another one on. So we've got like we could do a diameter dimension off of here, let's say, and luckily it's coming up the same as up there, the 42.05. But it automatically put that little diameter symbol, the little circle with the line through it, because it knew it was a diameter. We've got angled dimensions, which I don't really have. Well, actually, I do. Look at this. So we can do an angular dimension. Let's do that on this detailed view, maybe between like, this surface and this surface, right? So we could, put a dimension on that. And so it knows that it's an angle, and put that in place. What else for dimensions? Oh, another thing we can do is we can change the size of text, or we can add text. So for dimensions, you can have it arranged dimensions or aligned dimensions so that they're evenly spaced out. Sometimes you have features where you have multiple dimensions kind of next to each other. That's one there. Then going across the ribbon, we've got text. We can add notes, or we can add note with a leader or something like that. Like we could add a leader note maybe to like the gear teeth. Let's say maybe to here. And so now we can type in, and we could say something like 30 degree. Actually, let's add the little degree thing in. 30 degree helix. Oh, I can get back into my typing there. Come on. Get back to typing in that. 30 degree helix. 30. So we also can see it. Use that degree symbol again. So if I want to add a symbol, I can use the little drop down. 30 degree pressure, angle 27, something like that. So to help define things about, like, let's say the gear pitch that might not be apparent from the model. So we can add notes like that. We can also just add a text note. Like we'll just add a text note down here at the bottom to, let's say, maybe tolerance. Use that symbol for, there's a plus minus 0.1 millimeter less, otherwise specified. We can also change the height of our text. So we can add notes. We can add a material note. We say material A2 full steel, something like that. Anyway, so you can add different things that might be of importance to either you're checking the part to make sure it fits your application or to the machine shop that's making it. It looks like there's a bend note text, which if you're doing a sheet metal part, you can have a note specified so that the arrow of it, the leader line arrow, is pointing to the bend radius center line. There are also symbols. We have symbols for like surface texture or welding, the welding symbol. But let's say so let's put one on for surface texture for like this edge, this face here. Yeah, on this line. So we can put I know what we have to do. So this is the surface for the bore here. And we can put on a surface symbol, surface finish, and then we can type in the specs that we might want for surface finish. I have to cheat a little bit. I don't know surface finishes right off the top of my head, but I can see that there are some. I was looking up some specifics on surface finishes before. So you have roughness values and machine allowances, and depending on what you put in is where it will show up around the symbol. So like this one is saying that it has to be, it's got the lay symbol, or the perpendicular, it has a certain perpendicularity, and then, you know, the different, the length of which you're testing your surface, and then, you know, the maximum waviness that's allowed. This is just a web page I found from a Google search, but it shows you a little bit about surface finish and about how, you know, depending on the roughness of an object, how that's specified. Oh, so I guess that lay direction is the direction of the surface finish. So perpendicular would mean it would be going crosswise to the object. But anyway, this is where you would put that information in. So if we want to do a roughness of 0.01, could be 0.3 to 0.06. And we can put in that sort of a note. You can also insert an image or a picture if you want it into your 2D drawing, your blueprint, or tables as well. If you have any information that would be useful to lay out in a table, and then when you're done with your whole drawing, you can export it as a PDF. So you can actually export it as a few different formats, but I find PDF is the best. So if you do export, you can export, either all the sheets if it's a multi-sheet drawing or just a single sheet. And we can open it when we export it. So we'll save it here for now. And there we go. So now it has turned that drawing into a PDF. And so now I could include this with the step file. So if I wanted to create the step file, I would go back to that original part. And I could there's a few different ways I could do it. I could either do save as, or I could do export. I could export it as a step file. That's this one, STEP. And I could save it that way. I think you can also, from your part of your body, you can, I think there's save as a mesh. Save as a mesh is actually an FTL file. This is what we use when we're doing the 3D printing. So yeah, so the step file is the better choice for CNC machining. Oh, another thing, going back to the drawing, um, another thing we could call out is like threaded holes. That's a great thing to use a drawing for, is to call out a threaded hole to specify, like this hole is not threaded in my part, but if it was, I could easily make a like a text with a leader line, and I could like click that little circle and come up to here, and let's just say this is you know, an M3 you know, red or something like that. So that way, you know, there would be no ambiguity to a machine shop to make that. And then once you know you're done, you can save it, and it will save it into your project file, and you're good to go. And so then if you were going to then send this off to a machine shop, you would include your step file and your blueprint, and you'll let them look at it and analyze it. They would come back and give you a quote on what it might cost to make that. Trying to think if there's anything else I've missed drawing wise. This was that one that I'd done earlier on that flywheel. So yeah, so I have, you know, a lot of the same kinds of notes and dimensions. You know, there was a few critical dimensions here that I wanted inspected from like the clutch mounting surface, or the flywheel mounting surface to the clutch plate surface. There was a few diameters I needed tighter tolerances on for bearings. I specified my holes here. So out of the 6 holes in the hexagonal pattern, 1 hole is offset so that it's keyed and can only go on one direction. So I make a note of that, you know, 6 holes on a hexagon pattern except one, see 48-degree angle, and then I specified the angle of that 1 hole here. I also, the radial pattern for the holes on the perimeter, it's a 12-hole radial pattern, but there's only 9 holes. There's 3 holes missing every so often, so I specify that. I specify the material. I specify you know, all measurements are in millimeters. I specify a chamfer, specify tolerances, and then I say, you know, C3D model for non-critical dimensions, and I call out the press fit for the pilot bearing. So, and I put my name on it and a date on it. But yeah, these are kind of standard, you know, drawing features that that should be included when possible. I probably have a few other. Sometimes it can be very simple. I did one for alignment stand. Did I? Maybe I didn't do that one. I thought I did a simple one with a threaded part in it, but maybe I didn't actually save it. Let's see here. Oh, I know that there's like a relatively simple drawing for, yeah, this little throttle body flange, a little kind of square part with a hole in the middle. Right, so here's a relatively simple part, just a little, you know, rectangular or square plate within a hole in the middle that has a little step, and then 4 threaded holes, right? So then this was a pretty simple drawing to make. I just specified my dimensions for making sure that the hole locations are accurate. Again, I specify the material type, the tolerance, and then see the 3D model for anything that's non-critical. And then I specify the threaded holes. So M6 thread 4 times on the part. So that about covers what I have to say about making 2D drawings. You know, there's a lot of features in Fusion that, you know, there's a lot of options. You have, you know, you can create the different types of views. Again, you can put on the you know, different isometric views or different projections at angles. But in my mind, the goal of a good 2D drawing is to keep it simple enough so that the part can be understood, and that, you know, any critical dimensions that, again, you might want to be inspected or that might be ambiguous or unclear to the manufacturer, adding notes and things like that to just again help make this and make it clearer. And the more you work with sketches and make things, you'll become a little bit more proficient at it. But it's really kind of a direction guide, right? We as engineers, we don't write paragraphs of written stuff on how we want something done. We have to explain it through 2D drawings and notes. So there you have it. That is making drawings. Are there any questions?
None for me. I mean, this looks great. Thank you for the presentation, Ben.
Good. Good. I'm glad.
If I got this drawing, I would want to quiz you as to which side of the plate the M6 thread was supposed to go on.
Yeah, so that's a good question. It's actually, it doesn't show it here because you can't see where it is, but I can pull that file up, and if you had the solid model, it would be kind of apparent that it goes all the way through. So yeah.
That's what I figured. Yeah.
Yeah. So there are actually symbols for like counterbores and countersinks. They have some of those show up in either the symbol or the notes here. If I go to edit this text, yeah. So this is like a depth. So like if I wanted to specify a hole that did not go all the way through, let's say the part was 50 millimeters, I could say, use this symbol in the depth and say, that it's going to go down 40 millimeters deep or something like that.
Is there a resource that teaches you all these different symbols and these notational techniques?
There probably are online. I can't say I know of any right off the top of my head. I've just been around them long enough. I've kind of figured a lot of them out. This is their diameter. This is their plus and minus for the tolerance. Actually, we get a little pop-up. This is our degree.
Yep.
This is square. We got center line, or it says center line, position. So anyways, so this is the counterbore. I guess this must be a countersink. Counterbore is where it's square on the edges. Countersink is for like a taper head screw.
Right.
We've got our depth. So then we go circular sections. So yeah, I guess hovering over helps with some of them.
Yeah.
But yeah, the general ones are, that I have typically used: diameter, plus minus, degree, maybe the counterbore and the depth. That's probably most of what I would use.
Gotcha. No, fabulous. Thank you so much.
Good.